Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll discuss solutions to the questions in Paper 1 of the 2013 JEE Advanced Physics paper. The order I'll be following will be the same as in Code 0, but in any other order the questions will be the same, just the order will be different, so you can figure that out for yourself. In this paper's question, you are given two rectangular blocks having identical dimensions, and one of them has conductivity K and the other 2K, and the temperature difference between the ends is the same. It takes a certain amount of time to transport the first one. How much time does it take to transport the second one? Now in questions like these, a lot of the times people try to do it in their heads very quickly. I certainly did when I was giving my exams, but you tend to make a lot of errors in those. So the best way is to do these systematically, and it doesn't really take a lot of time if you do this properly. So I'm going to do this as systematically as possible. The general equation for us is delta Q by delta T is equal to Ka by L delta theta. And we'll just apply it to both the cases. In the first case, the two rods are in series, so we can see that the resistance will add, right? And it helps to write it in the form of delta theta is equal to delta Q by delta T times L by Ka, because then it becomes like V is equal to I times R. This is like V, this is like I, this is R. So L by Ka plays the role of resistance, and I do that because you can already use the results of resistance in series and parallel because you've already done them in mathematically similar cases like Ohm's law. So in the first case we have delta theta is equal to delta Q by delta T1. See, the amount of heat is the same in both cases, and the temperature difference across the ends is also the same in both cases. So delta Q and delta theta will be the same in both cases. In the first case it's series, so we'll have the resistance being added up, and the blocks have identical dimensions, so we'll have L by Ka plus L by 2Ka, right, which becomes delta Q by delta T1 times 3L by 2Ka. And in the other case, we have delta theta is equal to delta Q by delta T2. Now they're in parallel, so their inverse will add up, and then we'll take the inverse of that. So you'll have Ka by L plus 2Ka by L inverse. So this will be 3Ka by L, so inverse will be L by 3Ka. So delta Q by delta T2 is equal to L by 3Ka. Now you just divide the two. Delta theta will cancel, delta Q will cancel, L by Ka will cancel. So what you're left is the first equation divided by the second equation. This is not into, this is into. So the equation will be 1 by 2 will be 1 is equal to delta T2 by delta T1 into 9 by 2. And delta T1 is 9. So this gives us delta T2 is 2 seconds, which means the answer is same.